Hello students, good evening all. Welcome back to the chapter Hyperbola. So let me brief you about what we did or recap what we did in the last lecture. In the last lecture, we saw what is hyperbola, some standard definitions of hyperbola such as latus rectum, center, vertex and all, the two standard forms of hyperbola and the equations of tangent at a point. So the tangent part is remaining. We have only completed one of the equation. So let me tell you what we'll be doing in today's class. Today we'll be continuing with hyperbola or tangent part, and then we'll see auxiliary circle, the asymptotes, which is new in hyperbola. As I already told you, if you know the formula for ellipse, it is same as hyperbola except the two formulas. Correct, guys? So without further delaying, let's start. Welcome all, welcome back. Chalo. So the last lecture, let me tell you, we saw the equations of tangent at a point. So here in this lecture, we'll be seeing these equations. Now, again, the equations are same or very similar to ellipse. If I want to write the equation of tangent in slope form, that is what we do. We write the equation of tangent y equals to mx plus c, and in place of c, we use the condition for tangent c, which we did in the last class. So in place of c, we put plus minus a square m under root of a square m square minus b square. After that, we get the point of contact. Please let me tell you, point of contact also we did in the last lecture only. Yeah, this is the point of contact. In the last lecture, we did the same thing. Correct, guys? So here also we did point of contact. I'm just summarizing it. Next, obviously there will be two tangents drawn from an external point. Any second degree curve, guys, circle, parabola, ellipse, hyperbola. If tangents are drawn from external points, there will be always two tangents. Correct? Chalo. So let's see what we have next. Yeah. This is important as we did it in circle, parabola. This is just, it must feel like a revision to you all, so you'll pay attention here. If M1, M2 are slopes of the tangent 2 through P, that means through a point, external point P, there will be two tangents drawn. And the roots of these equations, which is M1, let's say, and M2, are the roots of the quadratic equation, which will give us the slope of the two tangents drawn from the external point P. Correct? This will give us the slopes of two tangents drawn from external point P. Now, as we know, this is a quadratic equation, so sum of the roots will be 2x1 y1 upon x1 square minus a, and product of the roots will be c by a, y1 square minus b plus b upon x1 square minus a. I hope it is clear. Now please remember this, we are going to use this definition in director circle. Okay, so let's see what we have next. Before moving to next, we have one more lecture for conic section, which is the next lecture. So we'll try to complete the theory part in today's session, and tomorrow we'll do some numericals. Also, guys, we'll be doing JEE previous year questions. That means the 2020 latest questions of hyperbola in coming Saturday and Sunday. So please don't forget to attend that. Okay, we'll do some basic questions tomorrow, and Saturday, Sunday, we'll do the JEE main questions. Okay, chalo. So these are the MCQs. For the MCQs, let me open slideshow. Yeah. So the MCQs are if P lies inside the hyperbola. Come on. We did this. This is position of a point with respect to the hyperbola. So here point P lies inside the hyperbola. Excuse me. So what does it say? Yes, come on guys. It will be S1 is greater than 0. Please remember, in last lecture also I mentioned in ellipse and hyperbola it is exactly opposite. Right? Next. The equation of tangent. Very simple, guys. The equation of tangent of the hyperbola is t equals to 0. Simple. Next, the condition that the line is a tangent to the hyperbola is. Please don't get confused in ellipse with ellipse. In ellipse, it was c square equals to a square m square plus b square. But in hyperbola, it is a square m square minus b square. The correct option is third. Got it, guys? Chalo. And the next topic is the director circle and the auxiliary circle. Now, director circle and auxiliary circle. Both of them, which we have studied in ellipse also. Please remember, auxiliary circle are only there for ellipse and hyperbola. They are not for parabola. Correct? So let's see what we have. The director circle. Now, the definition of the director circle, excuse me, 1 second. The definition of the director circle we already know, which is the point of intersection of perpendicular tangents. The point of intersection of perpendicular tangents. Excuse me. I've got cold because of the weather. Yeah, it's called the director circle. Now the tangents are perpendicular. Please remember, I just told you to remember that equations, which were the quadratic equation which we got, whose roots were m1 and m2. So if the roots are m1 and m2, then we got product of the roots. Now, if both of the tangents are perpendicular each other, that means the product of the roots will be -1. It will be -1. So if we use that, so we can easily get the equation of director circle, which will come to x square plus y square equal to a square minus b square. This is the equation of the director circle. I hope you remember it. Correct? So x square plus y square equal to a square minus b square. Now, let's proceed for the next part, which is auxiliary circle. Now, the feet of perpendicular. Now, please remember, definition remains the same. Same was for ellipse. What is the definition, guys? The feet of perpendicular drawn from foci to any tangent to the hyperbola. That means if from focus I draw foot of or feet of perpendiculars to n number of tangents that are on the hyperbola, then those feet, which is called auxiliary circle. So, if the hyperbola is x square upon a square minus y square upon b square equals to 1, then the equation of the auxiliary circle will be x square plus y square equals to a square. Please remember here, the major or you can say transverse axis is x-axis. That's why if x-axis is a transverse axis, then here the radius will be a square. If y-axis is the transverse axis, then the radius will be b square. Okay, please listen to my words very carefully, guys. What will be the equation of this auxiliary circle? Just now, that's why I told you. Here, the transverse axis is the y-axis. If the transverse axis is the y-axis, then the auxiliary circle will be, or the radius will be b. So it will be x square plus y square equals to b square. I hope it is clear. Now, just a second. I think we here we have to P. Yeah. So now we are good. Now we have the standard results. What are the standard results, guys? The chord of contact, the pair of tangents, and chord with given middle point. So the results remain the same. The equation of chord of contact of the point P, x1, comma y1, with respect to hyperbola is t equals to 0. Same as tangent. Excuse me. Same as tangent. The equation of tangent is also t equals to 0. Now, next is midpoint of a chord. That means the equation of chord with middle point as p x equals to, sorry, p x1 comma y1. Then its equation will be t equals to s1. It will be t equals to s1. I hope you remember this. Next, we have the pair of tangent. What is it? What are the pair of tangent, guys? It is S1 is equals to t square when the tangents are drawn from the point P x1 comma y1. Excuse me. I hope it is clear. Just a second. Yeah. Now we have the next most, or you can say an important part of hyperbola, which was not an ellipse. What is it? You already saw it. It is asymptotes. You saw this. Yeah. What are asymptotes, guys? See, there are basically, we have seen asymptotes in various questions, you can say, or various concepts, but we did not know that asymptotes was what they are called. So, what are asymptotes? Excuse me. See, let's talk about asymptotes in general. Asymptotes are basically lines which, or you can say tangents, which never intersect the curve at any point. So let's say, for example, I hope you know the graph of 10x. If I try to draw the graph of 10x here, it will look like this. Correct. Now, if you see these two lines, here it is pi by 2, and here it is minus pi by 2. The 10x graph, or you can say the graph, never intersects. Then these two lines, x equals to pi by 2 and x equals to minus pi by 2. Why? Because tan pi by 2 is not defined. Tan pi by 2 is not defined. Similarly, such lines are called asymptotes, which never intersects the curve. But as we move closer and closer from the to the line from the curve, they both come closer and closer to each other. As you can see, as we increase the value of x, or we go towards pi by 2, the curve and the line के बीच का distance becomes smaller and smaller. Such lines are called asymptotes. Okay, so in case of hyperbola, so this is also x equals to pi by 2 and x equals to minus pi by 2 are asymptotes of tan x. Yeah. So in case of hyperbola, guys, what will be the asymptotes? The lines which never intersect, but as we move on the curve, they get closer and closer. So let's see the official definition. The official definition looks like this. The tangents of hyperbola which touch the hyperbola at infinity. That means which never touches the hyperbola. Basically, they just move parallel to each other. Are called asymptotes of hyperbola. Right now, obviously, guys, all the curves may not have asymptotes, such as ellipse didn't have an asymptote, or circle didn't have an asymptote, but hyperbola has. That's why we're studying in hyperbola. So, if I try to draw the hyperbola looks like this. What will be the asymptote? Please remember to draw asymptote. Basically, you just need to draw a tangent. But the tangent should be such that it does not intersect the hyperbola. So here, the asymptotes will look like these, the blue lines. As you can see, if I consider this blue line and I go forward and forward, the hyperbola and the blue line will come closer and closer, but they will never intersect each other. What does that mean? That means they will intersect at infinity. Such lines are called asymptotes. Now, for this hyperbola, do you know the equation? It is x square upon a square minus y square upon b square equals to 1. For this hyperbola, the asymptotes are, you can easily guess it from the graph. What does it look like? The asymptotes looks like they are the lines y equals to x and y equals to minus x. So this is the line y equals to x and this is y equals to minus x. This we just thought by seeing the graph, but let us see how the equation of asymptotes comes. Okay. So the equations of the asymptotes of the hyperbola, these we just now discussed, are this. How did we get it, guys? You can see the correlation. Instead of x square, just put x, a square, just put a. Y square y, b की जगह पे b. So if we try to cross multiply or so, we'll get the equation of asymptotes, right? So what will be the equation of pair of asymptotes? Pair of straight lines say. So the two different asymptotes, if we separate it, we'll get x upon a plus y upon b is equals to 0. The second one is x upon a minus y upon b is equals to 0. Now, to get the pair of straight line equation, we have to multiply these two. So if I multiply these two, you will get C, a plus b into a minus b, which will be a square minus b square. Correct? Which will be a square minus b square. That only we got the equation of pair of asymptotes here. The another thing to notice is the equation of pair of asymptotes and the hyperbola differ by a constant. That means here you will have 0, but here you will have 1. That means the difference is of a constant. In this case, the constant is 1 unit. Got it, guys? I hope it is clear. Now, let's see some points regarding asymptotes. The first one, asymptotes of hyperbola pass through the center of the hyperbola. Yes, we just now saw for the hyperbola x square upon a square minus y square upon b square equals to 1. The asymptotes pass through the origin, which was the center. Next point is, asymptotes are equally inclined to the axis of hyperbola. So for the standard hyperbola, guys, the equation or the axis was the x-axis and the y-axis. So the two lines which I draw were equally inclined to both the axes. That is 45 degree, right? It was 45 degree from x-axis, 45 degree from y-axis. Let me try to draw here. So if this is the hyperbola, then its asymptotes were this, which is the lines y equals to x and y equals to minus x. So these both angles were same, which were 45 degrees. Correct? Let's see the next one. Any straight line parallel to an asymptote of hyperbola intersects the hyperbola at only one point. That means it will be a tangent. Let's see what we have next. We have the MCQs. The equation of director circle. Come on, guys. What is it? What is the equation of the director circle? The equation of the director circle was x square plus y square equals to 7. How did I got it? I told you all to remember. X square minus y square equals to a square minus b square. So by comparing, this is a value of a square, this is a value of b square. That means it will be 16 minus 9, which is equals to 7. X square minus y square is equals to 7. Next. The equation of auxiliary circle. What is meant by auxiliary circle? See, this is the standard hyperbola where the transverse axis, I hope I have written the spelling right. The transverse axis is the x-axis. And if the transverse axis is the x-axis, that means radius or r squared will be equal to 16. So equation will be x squared plus y squared equals to 16. Excuse me, which is option number A. Let's look at the next one. The equation of asymptotes. I hope you remember how to get equation of asymptotes for a standard equation of hyperbola. Here we get x upon 3. Just take the square root plus or minus y upon 2 will be equals to 0, not 1, guys. That means this is clearly the option number 3. So it is correct. Now let's look at another thing, which is rectangular hyperbola. What is rectangular hyperbola? I think we have studied this word pehle also. You must have heard somewhere in mathematics, or you must have also heard, I think, in chemistry or physics. Excuse me. Yeah. So, what is rectangular hyperbola? So, rectangular hyperbola is nothing but the hyperbola when the asymptotes are the axis, which the coordinate axis. That means the x-axis and y-axis. So, when the asymptotes are the coordinate axis, then just a second, I'll put the chart here. Then the hyperbola becomes the rectangular hyperbola. So let's see how the rectangular hyperbola will look like. First, let's try to draw and then we'll see. So these are the coordinate axes, and this should act as the asymptotes. Now, if you remember, for the standard hyperbola, if I draw, the asymptotes were forming an x. That means the hyperbola was something like this in the branches of x. So here also, if you tilt your head 45 degrees to the left, this is my left, you should do like this. Then you will see an x, and that x के branches में, if it try to draw a hyperbola, it will look like this. So these blue lines are rectangular hyperbola. Either it will look like this or it will be like this, the orange one, right? So let me erase. You can see here we have the general definition of rectangular hyperbola. The length of its transverse axis will be equal to the length of its conjugate axis. What is the length of the transverse axis? 2a. What is the length of conjugate axis? 2b. That means if 2a is equals to 2b, that means a equals to b, then the hyperbola is a rectangular hyperbola. This is a general definition. We studied the rectangular hyperbola where the asymptotes were the coordinate axis. The eccentricity is root 2. Now guys, the eccentricity of rectangular hyperbola is fixed. It's always root 2. I hope you know how it will be root 2. How will it be root 2, guys? Okay, let's do it here. What is the formula for eccentricity, guys? It is b square equals to a square into e square minus 1. But for rectangular hyperbola, a is equals to b. Substituted here. So I'll get a square is equals to a square into e square minus 1. This will get cancelled. We'll get e square minus 1 equals to 1. E square equals to 2. This means e is plus minus root 2, but we'll only take positive values. Why? Because eccentricity of hyperbola is greater than 1. That means it's positive. So for rectangular hyperbola, the eccentricity is root 2. Okay, guys? Equation of rectangular hyperbola asymptotes are coordinate axes. Now, we already saw how do these asymptotes look like. Sorry, how does this hyperbola look like? But let's try to get the equation of rectangular hyperbola. If you know, if, let me, yeah, if the hyperbola is x square upon a square minus y square upon b square is equals to 1, then the equation of asymptotes are x upon a plus minus y upon b equals to 0. Here, there is 0, here there is 1. That means in this case, the difference between the constant is 1. So if someone gives me this part, that means the equation of the asymptotes, will I be able to get the equation of hyperbola? Of course, guys. We just have to find the equation of pair of asymptotes. So the equation of pair of asymptotes in this case will be x square upon a square. As we already saw, we multiply these two minus y square upon b square equals to 0. So this is the pair of asymptotes. So from here, you notice that this one, there is a difference of constant. Only difference between the equation of pair of asymptotes and the equation of hyperbola is the constant. In this case, the difference is of constant 1. But that might not be the case everywhere. It might be a difference of constant, any constant, 2, 3, minus 1, minus 2, any. So, let's say, let me erase this here. The equation of coordinate axes are x equals to 0 and y equals to 0. What will be the joint equation? Xy equals to 0. Now, if you noticed, oh, sorry. If you noticed, then the difference between the joint equation of asymptotes and the equation of hyperbola is just a constant, which is c. So this is the equation of the rectangular hyperbola whose asymptotes are the coordinate axis. I hope you got it. So is xy equals to c square. Now, we took the constant c square just to be sure that it is positive because squares are always positive. See, the rectangular hyperbola for this will look like this, correct? The rectangular hyperbola will look like this. See, the curve is in the first quadrant and the third quadrant. That means x and y either both are positive or both are negative. So if we put any point from the first quadrant and the third quadrant in the equation of hyperbola, it should satisfy. And it will only satisfy by multiplying. If we multiply, we'll always get a positive value. That's why we wrote c squared. But if someone takes the points from second or fourth quadrant, where one of the terms from x and y is negative, Then if you multiply both, we'll get negative value. But those point does not lie on this hyperbola. That means they should not satisfy. So the value of x into y will be negative, which will not lie on the hyperbola, which is proved by taking c square, not c. Okay? I hope I made myself clear. So let's look at the MCQs. The eccentricity of the rectangular hyperbola. Now, even if you forget, it's very simple to derive. It is root 2. Excuse me. Oh, the angle between the asymptotes of the rectangular hyperbola. Now, obviously, guys, it is asked in general, rectangular hyperbola. So, the equation of asymptotes will be x equals to 0, y equals to 0. That means what is the angle? It is 90 degrees. Got it? Next are the parametric equations. Now, this is the most important part again. For parabola, it was again a very important part. Ellipse, we did eccentric angle as the parameter. Parabola, we did small t. And in here, hyperbola also we have eccentric angle. So let's see what the equation looks like. Any point on the hyperbola x square upon a square minus y square upon b square can be represented as x equals to a sec theta, y equals to b tan theta, which is unlike in ellipse. In ellipse and circle, both were almost the same. But in hyperbola, we have used sec theta and tan theta, where theta is the parameter. That means if someone asks me to assume any point x comma y on the hyperbola, it will be a sec theta comma b tan theta. A sec theta comma b tan theta. So you can guess what is the equation of line. Let us read this. Again, this point is simply denoted by p theta, as it was done in ellipse. Next is the equation of tangent. It's very simple, guys. What is the equation of, what is the equation of tangent? It is t equals to 0. How to get t equals to 0? Replace x square by x, x1, y square by y, y1. 1 by 1. Now, p theta. That means the coordinates are a sec theta, b tan theta. If we substitute these 2 points in place of x1 and y1. We'll get the equation of tangent, which is this. Sorry, which is this. Because we did the same thing in ellipse and parabola. Next is, you guessed is correct, the equation of normal. Now this I want you all to derive. Come on, let's derive it together. Excuse me. Come on. We know the equation of tangent, which is x by a sec theta plus y by b tan theta equals to 1. What is slope of tangent? We do the same thing. We are going to find slope and then use slope point form. Is minus sec theta upon a upon tan theta upon b, which is v by a into sec theta upon tan. So what will be the equation of normal? Normal and tangents are perpendicular to each other. That means the product of their slopes will be -1. So what is the slope of normal? It will be negative reciprocal. That means a tan theta upon b sec theta. I think there is no need to convert into sine and cos because we already want in terms of sec theta and tan theta. This we need to glue, right? So p theta means the point is a sec theta, b tan theta. So y minus y1 is equals to slope m into x minus x1. If we cross multiply, we'll get by sec theta minus b square sec theta tan theta. Sec theta, sorry, is equals to ax tan theta minus a square sec theta tan theta. So let us group the terms together. So if I take this both together on the right hand side, I'll get ax tan theta minus by sec theta. And the rest of all, right, a square minus b square, you can take common sec theta tan theta. I think here it should be minus. Sorry, my mistake. And if we now divide by sec theta tan theta on both the sides, I think we'll get a required answer. So this will get cancelled, this will get cancelled, and a final answer will be ax upon sec theta minus by upon tan theta is equals to a square minus b square. This is our answer. Oh, sorry. Let's see the MCQs. The parametric equation of the hyperbola. So this is the first standard hyperbola. So it will be x equal to a sec theta, y equals to b tan theta. And last, the equation of normal. It is third. Correct? Did we made an error? I think here, oh, it is minus. Okay, here it is minus, guys. Sorry, so sorry. So here it will be plus, here it will be minus. So it will be minus a tan theta. So it will be minus a plus b. So we'll get plus plus. Here also plus and plus. Right? Sorry guys, it will be plus. No worries. So this was all from my side. So today's lecture is over. Thank you all for joining. I hope you understood the theory of hyperbola. In tomorrow's lecture, we are going to do MCQs, not JE. JE MCQs we'll always discuss on the weekends. Here we'll be seeing some basic questions, NCRT, Wednesday or CET level. And that's all from my side. Thank you all. Thank you for joining. Bye-bye. Take care.